Hello learners, so in this particular lecture we will see about the integer multiplications and Strawson's matrix multiplication, and we'll see another examples here that how is this being done. Again the theme of this particular thing is that we'll do it by divide and conquer method. So if you check here the integer multiplication, what is it? That you're taking simply two integer, when you multiply it, what will you get? Okay, so here two n bit decimal numbers x and y are represented as x n minus 1 comma x n minus 2, then so on and so forth until you get x1 and x0. Similarly for y, the same thing will be followed, that y n minus 1. So this is representing n minus 1 is representing its decimal value. So what it means is that it is placed on 100th place or 10th place, something like that. So the output you will get is a 2 n digit number because you are multiplying these two numbers. So in the end it is represented as the product is that x dot y. So it will be referred to as the product, and again you will get another value in another variable, that is z n 2n minus 1 and then z 2n minus 3, so on and so forth up to zn z1 and z0. Okay, one method that is being followed here, that is referred to as Karatsuba method. So what happens in 1962, a mathematician named Karatsuba has discovered that there is a faster way to multiply two integers with a complexity that becomes n raised to power 1.59. So if you see here, if you see normally when you multiply numbers and if you write it in a program, suppose you want to multiply 1 to 4 numbers with 1 to 4 numbers. Okay, so every multiplication. So if you write it in the form of a what you say in the program form, what will happen that you will place I and for I and for j. So there will be two loops. Okay, so when there are two loops, what will happen? The complexity becomes, for first loop it will be n, next loop it will be n. So because it is multiplying, so you can say that the complexity becomes n raised to power 2. So the multiplication complexity is always n raised to power 2, but this particular mathematician Karatsuba has discovered a method that is referred to as Karatsuba method, which is able to multiply it faster, and the complexity of this particular algorithm becomes n raised to power 1.59. So it's again following a divide and conquer approach that we have already seen in the previous lectures also. So now if you take a look here, so what they are doing is that you are taking a number x, they are dividing, if suppose there are 2 digit or 3 digit or 4 digit here. So what they are doing, they are dividing if there are 4 digit in number x, so they are dividing into two parts, 2 digit and then 2 digit. Okay, again the ceiling value that we have already seen in the merge sort and quick sort, the ceil value, suppose if there are 4 digit in x that we want to multiply, so if there are 5 digits, so what will happen, 3 digit will be in the first part, 2 digit will be in the second part. Okay, so now this is written as n by 2, the first a will contain n by 2 digit and b will contain n by 2 digit. So the value will be from x n minus 1 and then x n minus 2, so on and so forth, you will get x. Again you will another digit will be from x n by 2 or 2 till x of 1. Okay, so what is these digit is actually, if you multiply a by 10 raised to power n by 2 and you plus it with the help of b, you will get the same digit. I'll show you with an example of what I'm talking about. For another y, you have to perform the same method here for y also. So again y will be again divided into two parts, that is c and d. So what will you do? You take these c and d and divide these two numbers, and then divide this into two digits, and then again if you want to obtain the original number, what you do, you divide multiply it c with the help of with the 10 raised to power n by 2 and you will plus the d, you will get the same number y. Okay, so Again, if you see here, both the number x and y have the same number of digits. So this is one assumption that we are taking. So if there is x, there is 4 digits. In y, there also should be 4 digit. Okay. So if anyone has a lesser number, so what we are doing is that we are adding 0 towards the front. Okay. Suppose there are 4 digits and 3 digits. So suppose there are 3 digit number 389. So what we are doing is that we are converting this number to 0389, so that we are converting it into 4 digits, because 0 does not have any value when you are multiplying the digit in the starting. So that is why we are adding 0 here. So again, you divide the numbers into two parts, n by 2. So again, to obtain the original number, you can simply multiply it with part of another number raised to power n by 2 plus b. Okay, so I'll show you in the example. If you see here, so in the example you can see that there is a number x 102672, which is 7 numbers, and then there is another which is 6 numbers, that is 743914. So the first step is that you have to convert the numbers into equal numbers. So again, the next the 7, where there are 6 numbers, you have to again convert it into 7 numbers by adding a 0 to it. Okay. So now when you are dividing it into, because you have to take the ceiling value of it, because there is 7 and 7 divided by 2 will be 3.5, and when you take the seal of it, it will become 4. Okay. So you have to take the 4 digit number first, that is 1026, and the remaining number will be 732, which is the B part. A part will be 1026, B part will be 732. So in order to obtain the original number, what you have to do is you have to multiply it by 1000 and you add the another number. Okay. So 1026, you multiply it by 10 raised to power 3, because what is 10 raised to power 3? You have to take n by 2 of seal. So what happens here is that you take the number 1026 and multiply it by 10 raised to power n by 2. So n by 2 will be again taken the floor value of, because there are 7, when you divide it by 2, it will become 3.5 here, and then 3.5 floor value is 3. Okay. So you added 732 to it, you will get the original number. Similarly, in the case of 743, you are added 0 there. So 4 digit multiply 10 raised to power n by 3 and plus the another part of this, you will get the original number. Okay. So what we are actually doing is that we are taking 2 digits, firstly dividing into 2 equal parts. Now if they are even numbers, you can directly take the half, but if they are not even number, you have to take the ceiling value. Suppose if there are 7, you have to take the first, if there are 7 numbers, first will be 4, second number will be 3 digits. Okay. So similarly, we will follow this procedure, and now the computation part, where you have to multiply these digits x and y. So how is this being done? Okay. So first you take z equal to x dot y, and x dot y you already know what is that, and then you would raise it to the power of a 10 n by 2 plus b, and then again dot here c into 10 n by 2 plus d. Okay. So what is this actually? So it is these numbers that we have placed. If you just take these numbers and put it in an equation, you will get the same result. Okay. So what we are doing is that in place of x and y, we are writing 1024 into 10 raised to power 3 plus 732 dot 0743 multiply 10 raised to power 3 plus 914. Same thing. So if you write it in the form of variables, so it will be written like this. Now what you are doing is, what is actually x and y here? So x and y is nothing. This is we are just simplifying the value that we obtained. It means that that the value, that is a10 n raised to power 2 plus b, similarly multiplied by c10 n by 2 plus d. So if we simplify it, it will simply become a dot c dot 10 raised to power 2 n by 2 and plus bc plus ad, and then 10 raised to power n by 2 plus b and d. So if you check, the dot product here is actually how many multiplications you have to do. So if you check here, a dot c, so it is one multiplication, then c dot 10, so it is two multiplications, and then there is a multiplication of b dot d, that will be a multiplication. So there are three multiplications, and then there is a multiplication of bc plus ad into 10 raised to power n by 2. So it will be your one multiplication will be here. So there are total 4 multiplication require when you do this, when you simplify the equations in such a way. Okay, so taking the value x and y. So total 4 multiplications will be required. So how to write the recurrence relation of it? So you just simply take the value of 4t and you divide the list into n by 2. And how many additions you have to take here? So you have to take 2 additions, I think. If you see here in the simplified equations, there are 2 additions plus signs, and you are because it's a how many digit number? It's a 7-digit number. So you have to do n additions here. So how to write the recurrence relation for it? So firstly, you have to, for multiplications, what you have to write the equations that 4 multiplications will be there, and then divide the list into 2 parts, 4t n by 2, and you have to do the addition part will be a n work. Okay, so if you see here, when you do in this kind of way, the resultant will, if you solve it with the help of brute force or master's method, you will get a complexity of n square. Okay, so if you solve it with the help of master method, or you can solve it with the help of a recursion tree also. Okay, so now Carat-Suba, what the Carat-Suba has done, so instead of doing this way, he just reduced one, he can just reduce the multiplication by 1 if it is dividing and if it is following the divide and conquer method. So how? So instead, in the place of bc plus ad, so it can be simplified as b plus d and c plus a plus b and c plus d. Okay, so the bc plus ad part that you see in the previous example can be simplified as a plus b and dot c plus d. So what Carat-Suba has done is that taken this value and put it in another variable, that is u. So another variable, that is u. So it's also taken value v, which is referred to as a dot c in the previous equation where the multiplication is being done. Another value where the multiplication is done is b dot d. So it is taken into another variable w. Now just putting these values in the equation x and y that is obtained in the second equation, if you see in the previous example. So by just putting these values, if you can see, it is able to reduce the number of multiplications by 1. Okay, so here if you check here, there are only 3 multiplications that is being done. So for the first multiplication that is being done is v dot 10.10, and then the another multiplication is being done, that is 10 raised to power 2 dot n by 2. Another multiplication is being done is u minus v minus w dot 10 raised to power n by 2. So if you check here, there is only 3 multiplication instead of 4 multiplication. So the recurrence equations becomes, instead of 4t n by 2, it becomes 3t n by 2. So it's again 1 multiplication less, and if you solve it, it becomes n raised to power 1.59. By master method, if you solve it, you can see in the complexity part. So if you see here, rather than going the traditional way, if you are able to divide the problem into by following the method as divide and conquer, by reducing the multiplication, you can get a less complexity as compared to the previous method. Similarly, going forward, in case of matrix multiplications also. So matrix multiplication is a little bit different than the integer multiplication, because in integer multiplication there is only one element. You have to take one integer and you have to multiply it in another integer. But in matrix multiplication, there will be a matrix of 1 by 1, 2 by 2, 4 by 4, 8 by 8. So in this particular matrix multiplication, we always consider the 2 raised to power numbers. Okay, so what it means is that this is applicable for only those matrix which is either 2 by 2 or 4 by 4 or 8 by 8. So why it is so? Because we'll again follow the same thing, that the divide and conquer method. So if we have 4 by 4 matrix, you can divide that 4 by 4 matrix into 2 by 2 matrices. Similarly, if you have 8 by 8 matrix, you can divide 8 by 8 matrix into 4 matrix of 2 by 2. So if this is how divide and conquer method will work. Okay, so how this simple matrix multiplication is being taken care is that when you take in the value a where a is a matrix where I and j represent the storage and the store, how the I represent here the row and j represent the column. Similarly, for B matrix, again I and j is being represented where I represent the row and j represent the column. So if there is a 2 by 2 cross matrix, then B will also be 2 by 2 cross matrix, and the solution, that is C, when you multiply it with A by B, then the solution will also be in 2 by 2 matrix. Okay, so it will only work if there is a square matrix. It will the assumption is that. Okay, so how this work, that the first element of first row and first column will be divided with the first element of first row and first column with the second matrix, and the first element the first row and second column element will be multiplied with the first row and second row and first column element, and then you add these two. So this is how matrix multiplication works, and simply it can be represented in a summation k of I equal to n a of I k and b k j. Okay, so how this divide and conquer methods work? So if you simply do a matrix multiplication, if you write a program of matrix multiplication, it will simply be there will be 3 for loops, because firstly you have to first loop will be for A, second loop will be for B, third loop will be for multiplication and addition also. So there will be 3 loops. So it's easily n cube complexity that you will get in matrix multiplication. So how it actually works if you follow the divide and conquer method also. So suppose there is a bigger matrix, that is 8 by 8 or bigger than that, 64 by 64 matrix, something like that. So what you do is that, suppose in this particular case we are taking a 8 by 8 matrix. So you can divide this 8 by 8 matrix into 4 matrices, that is denoted here by n by 2 into n by 2 cross matrices. It means that what you will do, you will take 8 by 8 matrices and you can simply divide it into 4 by 4 matrices, and then these 4 by 4 matrices will again be divided into 2 by 2 matrices. Okay, so how will we do that? We'll take care of that. Suppose this we taken at 8 by 8 matrices. The A here, there is 4 matrices of 2 by 2 that will be there. So it is represented by A1 smaller one, and then A12, A21 and A23. So these are 4 matrices that is representing a bigger matrix. Similarly, B will be B11, B12, B21, B22. So actually it is not one element, it is the whole matrix. What it means is that A11 is a 2 by 2 matrix. Similarly, if we are taking 8 by 8 matrix, then A11 is a 2 by 2 matrix, A12 is again a 2 by 2 matrix, A21 is again a 2 by 2 matrix, A22 is again a 2 by 2 matrix. Similarly for B also. Okay. So now when you perform the procedure again, because it's a recursive method, what you do for 4 by 4 matrix, 2 by 2 matrix, you again simply follow these 4 steps. The 4 steps is that C11, how can you write C11, C12, C21, C22? Simply look at this equation. So you can simply write it with the help of this equation. That is C11 is equal to A11 B11 plus A12 B21. So this is that similar matrix multiplication that is being taken care of for C12, for C21, for C22, similar, very similar. Now, these are the 4 equations that will be used. Okay. So, if there are 4 equations here, you can take a look at the complexity here. So, because there are 4 equations, it means that there will be 4 times you have to perform this operation. So, the recurrence relation will, this is 4 times 4. So, 4 times will you have to perform this operation 1, 2, 3, 4 times. Now, if you take a look here that from line, if you take a look here of this algorithm that is being here. So, from line 1 to 7, because there are arithmetic operations that are also there. So, the complexity for arithmetic operation is constant. So, it will be 1. But the line 5 where we are recursively calling the functions again and again. So, what will happen here? So, suppose a bigger matrix that is 8 by 8 matrix. So, you divide it into 2 by 2 matrix of 4 matrices. Now, this is again 2 by 2 matrices. You have to perform the 4 operations on single matrix. Okay. So, have to perform 4 operations, that is you have to compute C11, C12, C21, C22. So, this is actually total of 8 operations that you have to perform. So, what will happen here is that so how these 8 operations will be there? So, simply the first 4 operations will be recursively calling. How? So, suppose there is a 8 by 8 matrix, divided into 4 2 by 2 matrix, and on every matrix, suppose I am taking only one matrix, that is A11. So, for A11 you have to call 4 operations, that is C11, C12, C21, C22, one by one. So, this is 4 operations, and after that you have to do 4 additions also. So, this is again 4 operations. So, total 8 operations on calculating one matrices result, one matrices 2 by 2 result. Okay. So, it means that 8 operations will be performed on every 2 by 2 matrix. So, the recurrence relation that can be written as 8t n by 2 by n by 2, because we are dividing the matrix into a smaller matrix, because 8 by 8 is divided into 2 by 2, and then with the addition, because you are multiplying, in the end you will get a n square complexity of theta as well. And when you solve it with the help of a master method, you will get a complexity of, you can check it, cube. Okay. So, this is how divide and conquer method is working, but there is another easier way that you can reduce one operation and you can get the complexity down to 2 raised to power n raised to power 281. So, what is this method? It is referred to as Strawson's method. So, what happens in this method is that these operations that you have to perform is written into 7 equations, P1, P2, P3, P4, P5, P6 and P7. So, it is written like shown in the screen, and similarly for 4 operations will also be there, but rather than performing 4 operations or everything, you just take a look at these 7 operations, you just solve these 7 operations one by one. So, the multiplication, that the work that we are doing was 8 is reduced to 7. Okay. So, now when you solve the recurrence relation on 7t n by 2 plus theta of n by square, you will get n raised to power 2.81, which is lesser than n raised to power 3. Okay. So, you can see the example for it as well, but if you follow these 7 magical steps, that is P1, P2, P3, P4 and P5, P6 and P7, if you are able to arrange your matrices in this format, you have to perform lesser calculations as compared to the previous method that we are using. Okay. So, what will happen here the addition operation is increasing, but the multiplication operation is becoming lesser. So, that is why we are able to obtain a accuracy, we are able to obtain a complexity of n raised to power 2.81. You can check the example yourself. So this is again, they are arranging the elements into 7 P1 to P7, and it is requiring less effort. Okay. So this is how the integer multiplication and Strawson matrix multiplication is being done. So in the next one, we'll see in the next one. Thank you.